Today I'm going to talk about advanced ngrx recipes. So this is entirely available on Angular 2, actually exclusively on Angular 2. Basically the topic I want to cover is leveraging the add-ons that comes with ngrx that the team over there built, so that you can build like a strong architecture for your app and kind of give you some guidance so that you end up with an architecture that will be built to last. So I'm Xavier Lozinguez. So I'm the person on the left, on the right, if you can see. I'm the lead front-end engineer at Axia. We have about 12 engineers. We're also hiring. So if you want to work on all the latest Angular 2 and we're using ngrx, feel free to find me. When I give you a link to the presentation, you'll find all the good handles to find me on social medias. So what is ngrx? So this is great because Pavan actually talked about ngrx, did a quick introduction about this library back in November, I guess, and he outlined what it is. So ngrx is an RxJS-powered state management for Angular app inspired by Redux. So they basically took Redux and combined the powerful RxJS, which is the Reactive extension library developed by Microsoft, and they built like Redux-like implementation. So why doing this? So Redux CoreNet, you have a state that is a single immutable data structure. It represents basically a single source of truth. The second one is that action describes state change. The only way you can change the state of your tree that is contained in your store is by firing up action and giving payloads. And then this is the state changes through the use of pure functions. That's the only way that you have the ability to change your store. This is done inside of a reducer. So pure function uses a previous state and the next action to compute a new state. Finally, state is accessed through the store, which is an observable of a state and an observer of action. So let's look at the architecture overview and see how the pieces are going to fit together. So as I mentioned, like the store is going to be your single source of truth. It holds the state of the application at any given time. Then the view is actually going to display the state of the application by plugging into the store. And then the user, by doing certain actions on your view, is going to dispatch action back to the store for the reducer to consume and mutate your state. So you see that that's a unidirectional data flow that's going to enable you to ensure that at any given time you have predictable behaviors and display on your app. So this was a very simplistic approach, and what I want to show you today is that when you start building up on this store and this ability, you start having multiple reducers to handle the different state of your application. I mean, the different part that compose the state of your whole application. You're going to end up having components that are going to look at the store and want different data to be able to display it back to the user. So it becomes a little bit more complex, and this is basically the approach that I recommend taking. So we're gonna go a little bit in details about these different pieces, but the things I want to bring to your attention is that by using selectors, you have the ability to take just a piece of state from a store that you are interested in displaying to your user. So you can reuse the component. You can reuse the selectors to feed into your components. So these components are usually the ones that are plugged into the store are called containers or smart component. And then those sub-components, the one that I call sub-component, are the ones that are deemed dumb component. They only care about how the data is going to be displayed, and that's all they care about. They don't do any business logic whatsoever. And then after, what's going to happen is your component is going to fire up actions, and that's going to be mutating your state. It's going to change your state of your application. So if you look around the actions, there is what we call ngrx effects, and we're going to look into that, how it's going to help us build a better hierarchy. But basically, you're going to have actions that are going to be consumed by those effects, and those effects are going to be, in turn, calling API services to perform all your HTTP data fetching, data handling. On the other hand, you have those what I call socket services that are basically pinging your application and firing up action by themselves. So there's a difference into the way you have to think about those services, the services that you want explicitly call, and those that are just pinging your application and firing action that are going to be by the reducers, consumed by the reducers to change your state. So first things first, I want to show you a little bit of the demo app. So my subject today is going to be a computer science classic, sorting algorithm. So how many of you can guess which sorting algorithm this represent? Chauvin, yeah, good. Bubble sort. Great. So this is the application, and what it does basically, you're going to enter your different elements, your different items in your list, and then you're going to select which sort you want to apply, and then simply click sort, and it's going to output all the steps that your algorithm is going to go through to end up with a correct answer. So let's look at the component hierarchy, so that it gives us like that nice schema that I was outlining in theory before. So we have an item manager here with input to enter your items, the ability to add those items and to reset that list. Then you have the list of items, self-speaking, that is going to just display what you're actually currently sorting. Then you have a list of steps, and what I call the sort pick component. The hardest part for me is always to name those components, but I call that sort pick. So this is where you're going to select which sort you want to apply, and then the ability to sort, and also the ability to clear the step list. So looking at the store, this is completely deliberate. There is two main reducers. There are going to be the item list reducer that's hold the collection of items that are here numbers, and then you have a step list which holds a collection of steps, and steps is actually each step is going to be a collection of items. Also, that step list is going to hold the sort type that you have selected up there. That's one way to organize this application. There's many more. It's very, very up to you how you want to put together your store. By the way, I want to bring up to you that this tool is completely available directly into your browser, into your developer console. It's the Redux dev tool, and you can plug it. It's the great advantage to use these kinds of tools, because you can reuse whatever React put together, and just for our benefit. So the dependencies to our store, and basically the way our component, the store are going to be displayed by our component is as follows. You have the item manager and item list that are basically window to look into your item list store. And then on the other end, you have a list of steps and a sort picker that are windows to the step list store. So let's look at how, from this angle, we select what we want to display and how we do that. So this is called state slicing and state projection, and for that we use selectors. So here we have a very, very easy selectors, be much more complex. But basically what slicing state means is that you take just what you're interested in. If you look at the way our store is composed, you have a sort type that is part of our step store. And here, by just using the .select on my step store, I can just pick whatever I want. So that's slicing state. So this is immediately very simple. Could be a lot more complex. You can start doing all sort of operation if you wanted to. Then after, what you want to do with the state that you select, you want to project so that you can create something completely different. So if I want here, I'm taking the list of items from my item list store. I'm going to take the sort type from the step store, and then I'm going to project any state that I want. If I want to create like an object that has the value and the sort mechanism, the index, I can do really whatever I want and output an object that has nothing to do with originally how my store is put together. So if we look at the store, if you look at the store as a database, your reducers are your tables, and your selectors are your queries. Hence why I say selectors are to store, what queries are to database. So because we use Redux, I mean, ngrx is Redux inspired, and actually is implementation of the same Redux concepts. We can actually use other React tools, such as reselect, which is going to be very handy when it comes down to create state slicing and state composition. So what we're going to do is extract selectors within our stores, and we are going to create observables to extract information that's actually going to be modified. Here we are going to get the step count, which is basically the measurement of how many steps you took within your step list. And then what we take those selectors, we take the result of the selectors, and we use it directly in our components. So what this does is very powerful, because you can create your selectors within your store or in another file if you wanted to, and keep it outside of your components. You don't have to do all this complex calculation. Here it's pretty simple, but you could imagine having to plug into multiple reducers and having to create with an object that is much more complex than this, just to feed into your components so that it can display the data appropriately. So having the ability to do so is going to yield many benefits. Simplicity, you have a store that holds the minimal possible state, so you don't have to manipulate your store, so it starts to conform to the components that you want to implement. It's completely agnostic in that sense. And you have efficiency, reselect, implement memoization. What it means is that unless one of the arguments changes, the value is held for every selectors, even if it's shared across different components. So you can have many components that are actually going to use the same selector, and the value won't be recomputed for each component. It will be only calculated once. Composability, which is actually pretty cool. So now you can start thinking that selectors could be a composition of multiple selectors. So this is where you start to split your selectors into smaller pieces that are going to be much easier to actually test against. Maintainability, you have less redundancy, because imagine you have a component that are doing kind of the same thing, that are going to need the same data. You don't have to write the selector twice. You can use the same selector. And then testability, those are pure functions, so it's extremely easy to test. And also, you only have to test those information once because of a dry principle. So let's jump into ngrx effects. So if you remember the big picture, the selectors are feeding the view basically helping us filling the components so they can display data to the user. Effects are on the other hand, when a user is starting to do certain actions on our components, this is where effects are going to show their efficiency. So everything is a stream, even actions. So effects, side effects model for ngrx star. It's action in, action out. It means that if I perform a certain action, I can implement an effect that is going to look for these actions to be triggered. And if it's one of these actions that I'm interested into, then it can fire up other actions. So you have like kind of waterfall, like a ripple effect of sort. Let's look into it. Action in, action out, enable to have the ability to compose new action source from targeted action. So in this example, which is implemented into our demo, you basically I implemented an app effect, but so you import the different actions on the step list and the item list. And what I created is a reset item list effect. So if you remember the interface, and we're going to look at it in a second, basically what this means is that every time I add an item or remove an item or I click the reset button to reset the item list, I'm going to fire up the reset step list action. And this reset step list action is basically going to wipe every steps that are into the step list store. So let's look at it as it's working. So here I'm already have my collection of items. I'm going to sort. So here I fire up all of my different step sort. And then here, when I click, it wiped everything up. So this is kind of like, this is one click. It fired up like reset item list. Then it went through reset step list and remove the item. And then it fired up remove item success because here I hooked up the DB. So I'm going to go into that. Cool. So basically, in one action, I fire up one action. It has a ripple effect. It clears all the steps and everything. It would do consequently the same thing if I add an item or if I remove an item. Here, I'm going to look into ngrx DB. So ngrx DB is the ability for us to store data directly into IndexedDB. Fortunately, it's not usable right now, apparently. I mean, at least it was 2016, so I don't know what happened since, but I mean, I'm still going to use it. So the setup is pretty straightforward. You're going to outline the way your store is going to be organized. Here I have a list of items. That's what I'm interested in storing. I have a primary key and ID, and it's auto-incrementing. I mean, nothing complex about that. And then I'm going to leverage the power of FX, and I'm going to create an item list FX that is going to instantiate the DB over there. It opens the connection to the IndexedDB, and then I go back to normal effects, basically. I'm going to here load the item list, which is going to whenever I'm going to add an item, is going to store the item. Actually, this is another one. This one is actually the one that whenever my app is actually loading up, is going to look into the DB, query for the items, and then load it up if he has any item into memory. Let's look at how it works. So here I have nothing in my DB. I'm going to enter several items. So unfortunately, the IndexedDB doesn't. I have to refresh. It doesn't use observables. Otherwise, I would see them popping up. And what happened is that here I refresh my browser, and my items are persisted because I simply it simply fetch everything directly from my IndexedDB. So it works pretty well. There you go. I'll replay again so that you can see. So here I'm entering the items. They are in my IndexedDB. And then I'm going to go and reload. The problem usually is that normally your store is wiped out. It's reinitialized. Here, because of IndexedDB, I can load it up. So that's pretty powerful. Let's look into meta reducer. This is a whole different item. And so what are meta reducers? Meta reducers are basically wrappers around other reducers, and they are going to look at the different actions, and they only dispatch other meta actions. It's basically as simple as implementing another reducer and then wrapping the reducer around. So immediately, the meta reducer, now that we know what effect does, basically, I've limited application. Here, for the sake of demoing how it works, I created an exception handler meta reducer that when it sees that the action type DB load items fails for some reason, IndexedDB didn't manage to give me my data because it was not responding or whatever. It's just going to output a console log. So if you look at it, it's not actually changing anything as far as the state is concerned, because it's just returning the original reducer so that it can do whatever it needs to do in the first place. So let's look at how it works. Here I'm going to use the tool to fire up to dispatch that action that I was looking for, and you're going to see that the console log is outputting. So here I'm going to fire up I'm going to dispatch that action. And when I dispatch that action, it's going to put console log index DB load fail. So that's pretty powerful. Once again, with effects, this is almost, there's like very limited usage. The only usage I could think about was around undoing and redoing. And even then, there are like some gotchas around that. And so basically, these are not very promoted to use. But I just wanted to display because maybe you would have a better application for it. Cool. So as I was using that for application, it came to mind that sometimes I have different components and they use different data, and I was against having that gigantic store holding all my data. So I was thinking, like, how about my component actually holds its own store so that you can bind it together, and then when you actually composing your app from those different components, you would compose your store at the same time. So that's what it's called, store composition as a consequence. And I think it would be great. So what it looks like is that here we have one store that is central to the whole application and the way it's powered. And the component plugs into it using selectors. And what I was thinking is more of this, basically. I still have my store, but my store is composed of that little blue star that is the store of component A, and that orange star that is the store that my component B is looking into. Maybe I have another component that actually doesn't have a store. So I was thinking about that. And actually, the good news is that this is actually coming up. You have the ability to actually subscribe to compose at runtime your store using that very mechanism. Right now, this is targeted for Angular 4. Angular goes so fast, they didn't go 3. They're just like, all right, whatever. I don't know, they don't like it 3. So actually, yeah, that's actually upcoming. I think it's very powerful, especially for separation of concern. And I think that would be very interesting to see what you can do with that. So you say, all right, cool, but I'm not using NG2, I'm still using NG1, so what can I do? Well, actually, Netflix and Redux, basically they implemented the very same thing, exact same thing with Redux observables. And I really encourage you to look into that, because for me it was like mind-changing, and plus the people that are pushing that are pretty awesome. They have pretty awesome talk about how that works, and they have a great documentation. The only difference is the naming. ngrx store is Redux, ngrx is Epics. So that's that. Basically, that's called Redux observables. If you're using Angular 1, that's what you want to use. I actually have a demo that's available for you to look at that actually uses Redux observables. If you want to see how it's implemented, it's exactly the same thing. And they have a pretty cool logo. I'm pretty jealous about that. ngrx doesn't have that. So credits, because I think it's important to give back, to acknowledge the people that brings us that. These are like the 4 go-to things I encourage everybody to look into. Introduction to Redux to understand how this works. Reactive Angular actually is one of the front-end master course led by Lucas. Then we have like a great introduction of the ngrx store available, and the last one is a Redux application with Angular 2, RxJS, and ngrx store, which explains like in great length how this works. And this is available on Egghead. I encourage you to look into that. This is great. And thank you.